We're working today on this sample HSC question about population of foxes on an island. So I've worked through this a few times, had a bit of trouble the first time. I'm going without notes this time and we'll see how we go. So we've got a logistic equation, dy dt equals y1 minus y. Notice there's no k there, which means that in the place of the logistic equation, k equals 1. And y is the fraction of the island's carrying capacity reached after t years. So notice that y is a fraction. So basically y is between 0 and 1, which is why, no pun intended, which is why this number here, which would normally be like our maximum population or something, our maximum value is 1. All right, so before we even start, we know that this thing's going to have a maximum value of 1 and something like, well, actually, at time t equals 0, the population of foxes is estimated to be 1/4. So here's our thing divided into quarters, and so something like that. Right, that's our that's y versus t. Anyway, we're doing some strange things with this. So we have used the substitution y equals 1 over 1 minus w to transform the logistic equation into dw dt equals negative w. A little bit hard to make sense of what we're really doing here, but if we have y equals 1 over 1 minus w, or y equals 1 minus w to the negative 1, then straight away we can get dy dw, which is probably helpful. So that's negative, and then 1 minus w to the negative 2, and then we multiply by negative 1 because of the chain rule. So this is 1 over 1 minus w squared. Okay, so dy dw is 1 over 1 minus w squared. All right, so I'm going to take this, and now what do? We want to get dw dt equals negative w, so let's just write down what we want here. dw dt, definitely some chain rule going on here. So that's dw dy times dy dt. And dy dt is something that's given to us up the top of the page here, so we can use that. Now, okay, I've got dy dw equals 1 over that squared, so dw dy, which is what we need here, is the reciprocal of that, 1 minus w squared. Okay, so that equals 1 minus w squared times y 1 minus y. Now 1 minus w squared, what do we want an answer here? We want negative w. So we want an answer in terms of w. And so taking, right, so here's just a little aside, taking y equals 1 over 1 minus w, what I want is I need to turn this in terms of w. This is already in terms of w. If I can get that in terms of w, because I need dw dt to be in terms of w. So I'm going to turn this around a bit. So 1 minus w equals 1 over y. And, oh, sorry, I don't need that. That doesn't help. This can be written in terms of w. I need that in terms of w, okay? So if I can just sort of show you my progress so far. So 1 minus w squared times, and then y, well that's 1 over 1 minus w, and then we've got this 1 minus y here. So let's look at what 1 minus y is. So 1 minus y is 1 minus, okay, that, and then okay, so there we go. So this is 1 minus w squared over 1 on 1 minus w times negative w over 1 minus w. And we can see here that this cancels with both of those, and we're left with minus w, which is what we want. Right, so dw dt equals negative w as required. Okay, done. Now, part 2, using the solution of dw dt equals negative w, so we're going to have to find that solution. Find the solution of the logistic equation for y satisfying the initial conditions. All right, just make some room for myself here. Don't need any of this now. All right, so dw dt is negative w. Just want to remind you, this is like, you know, dp dt equals like kp, right, exponential, and so here k would be negative 1. So because it's straightforward, I can feel like I can just write the answer down. So w equals ae to the negative w. Okay, I feel confident about that, and I'd just like to point out this is a 2-mark question, so doing a lot of derivation for this and then finding things on the initial conditions could be considered a lot of work, but I'll do the derivation here just in case we feel it's necessary, and indeed just in case I got something wrong by writing down the solution. dw dt equals negative w, take the reciprocals, dt dw is negative 1 on w, so t is that. I need a plus c, not there. Yep. Okay. And there we go. I did make a mistake here. That, of course, should be a t. Okay, so we've got that, and now we need to find a. So when t equals 0, we were told that y is a quarter, and so that means w equals what? So as an aside, we've got y equals 1 over 1 minus w, so quarter, 1 on 1 minus w, 4, 1 minus w, w is negative 3. Right? So when t equals 0, w is negative 3. And put that all in. Negative 3 equals a e to the negative 0. So a is negative 3. So we have w equals a, that's not what I wanted to write. W equals negative 3 e to the negative t. And now find the solution of the logistic equation for y, not for w. All right, and so we now have y equals 1 over 1 minus w. So y equals 1 over 1 plus 3 e to the negative t. That is the answer. And part 3, how long will it take for the fox population to reach 3/4 of the island's carrying capacity? Trivial question for 2 marks, so so 3/4 is 1 on 1 plus 3 e to the negative t, and we just solve for t. So 1 plus, take reciprocals, subtract 1, divide by 3, and I guess, yep, take the logs, negative t equals log of 1 on 9, or also known as negative log 9, so t is log 9. How long will it take? Well, do we have a units here? Yes, t equals ln 9 years. Done. Okay, so in that video we've looked at an HSC question. It's a little strange, a little unusual. We're using this odd substitution to get to a result to get to this result quite circuitously. We know from our own work in logistic equations that we can go directly from so let me clear this up. From this to like m being some maximum, 1 plus b e to the negative k mt. That's a very general solution. Here, the maximum is 1. So, okay, so the only unknown here is now k, and because k would normally be in that position and is therefore 1, then we can go, this is practically a write-down thing, okay? But in an exam condition, the people writing the exam are just seeing if we can do things that are unfamiliar, that's all. And yeah, I've got to say, I don't know that it's terribly hard, but it did catch me out the first time I tried answering it. And even now, having done the video, I haven't done a very neat job of it. But I decided not to do a prepared one for you because we should just see how we think our way through the steps. Okay, that's it.